Parallel lines cut by a transversal. Okay, we're going to talk about what happens when you have parallel lines that are cut by a transversal and the different relationships it creates between the angles. Given L sub 1 is parallel to L sub 2, this fancy symbol right here just means is parallel to, and I wrote that out right here so that would be clear. Line K represents our transversal, and then here are our parallel lines L sub 1 and L sub 2. Okay, so now that we've established all that, let's start off by talking about vertical angles. Vertical angles are angles that are opposite each other, and they are also angles that are equal to each other in measurement. So I'm going to go ahead and write that out. Vertical angles are opposite each other and they are equal in measurement. So angle A is a vertical angle with angle D. Because they're opposite each other. That means they are also equal in measurement. Angle C is a vertical angle with angle B. So that means they're also going to be equal in measurement. Angle E is a vertical angle with angle H. So these two angles are equal in measurement. And angle G is a vertical angle with angle F. So these two angles are equal in measurement. Okay, let's go ahead and we're going to write that out right down here. So I'm going to write here angle A and angle D are vertical angles. Angle B and angle C are vertical angles. Angle E and angle H are vertical angles. And angle F and angle G are vertical angles. Okay, I'm going to go here and I'm going to erase everything I shaded right here. Now we're going to talk about corresponding angles. corresponding angles are also equal to each other in measurement. So if we look here at angle A, the corresponding angle of angle A would be angle E. And if you look at A, it looks a lot like angle E. Just imagine we were to move angle A downward and it would land right here, right on top of angle E. It would fit perfectly right there if we were just to slide angle A down. So angle A and angle E are corresponding angles and they're equal to each other in measurement. Angle C and angle G are equal to each other in measurement. So if we look at these two, we can see that they look alike as well. And we could imagine that if we were to slide down angle C, it would land right on top of angle G perfectly. Angle B and angle F are also corresponding angles. So these two angles are also equal to each other in measurement. And angle D and angle H are corresponding angles. So these two angles are also equal to each other in measurement. Alright, so let's go ahead and fill these down here in our little chart. Start off here, corresponding angles. We started off with angle A and angle E. Right? And then we said that angle C and angle G were corresponding angles. And then we've got angle B and angle F. And lastly, angle D and angle H. So those are our corresponding angles. Now let's talk about our alternate interior angles. So the word alternate, what it means by that, it just means that they're on opposite sides of the transversal. Here's our transversal right here. So they have to be on alternating sides of the transversal. And then the word interior means that they're on the inside of the parallel lines. So in between the two parallel lines. So if we were to look here, which angles are alternate interior angles, those would be like angles C and angle F, because they're on opposite sides of the transversal and they're on the inside of the parallel lines. So why don't we go ahead and write this out a little bit here. Alternate interior angles are on opposite sides of the transversal inside the parallel lines. And they are also equal to each other in measurement. So angle C and angle F have the same measurement since they are alternate interior angles. Angle E and angle D are also alternate interior angles. So those two have equal measurement. So alternate interior angles are equal in measurement. Okay, let's go ahead and write those down in our chart. So we have angle C and angle F are alternate interior. And then we also had angle D and angle E as alternate interior angles. Alternate exterior angles. So you can probably already guess by the word alternate that they're going to be on opposite sides of the transversal, and the word exterior, they're going to be on the outsides of the parallel lines. So alternate exterior angles are on opposite sides of the transversal, and they are on the outside of the parallel lines. So here, A would be an alternate exterior angle with H. Since A and H are alternate exterior angles, then yes, you guessed it, they're going to be equal in measurement, because alternate exterior angles, when it comes to parallel lines here cut by a transversal, are equal in measurement. And the alternate exterior angle that goes with B would be G. So angle B and angle G are going to be equal in measurement. Okay. So let's go ahead and write that down here in our list. We said angle A and angle H, and then we had angle B and angle G. Right? You can see that right there. Okay, so now that we know all of these, then we should be able to figure out which ones of these are equal here. Oh no, I erased my transversal. Maybe I could bring it back. There, it came back. Okay, so let's say we knew the measurement of one of these. Let's say I knew the measurement of angle A. Let's say the measurement of angle A is equal to 130 degrees. Since I know that A is equal to 130 degrees, then that means D must be equal to 130 degrees because they're vertical angles and they're equal to each other in measurement. Alright, since D is equal to 130 degrees, then that means E is equal to 130 degrees. Because angle D and angle E are alternate interior angles. Or we could say angle E and angle A are corresponding angles. And since E is equal to 130 degrees, then that means H is equal to 130 degrees because angle E and angle H are vertical angles. Or we could have said angle H and angle D are corresponding angles. Or we could have said angle H and angle A are alternate exterior angles. So lots of reasoning there. Now if we're looking here for the measurement of angle B, well, A and B have to add up to 180 degrees because they make a straight line here. So if I subtract 130 from 180, I will get the measurement to angle B. So I can tell here B is equal to 60 degrees. Since B is equal to 60 degrees, that means C is equal to 60 degrees because B and C are vertical angles. Since C is equal to 60 degrees, then F is equal to 60 degrees because C and F are alternate interior angles. And since F is equal to 60 degrees, that means G is equal to 60 degrees because F and G are vertical angles. Okay, so this would be one way that we could use this information to find all of these missing angles. Okay, another way we could use this in algebra is when we have algebraic expressions in place of some of these angles and we're looking for a value of x. So let me erase some information here. I'm going to erase a little bit of stuff here. Okay, I might not be able to erase everything because I'm afraid I'm going to erase my lines, but we'll erase most of the stuff. Oh no, I already erased one of my lines. It's too late. There, it's back. All right. We're going to say that this angle right here is 30 minus 3x, the quantity 33 minus 3x degrees. And this angle right here is going to be 4x plus 9, the quantity of 4x plus 9. Well, if I'm being asked to find x in this situation, let's say here, find x. I can find x because I know that this angle and this angle are alternate interior angles, and therefore they're equal to each other in measurement. So I can set my two algebraic expressions equal to each other, and I can solve for x. So that's what we're going to do for this problem. Let me see if I can find a little bit of space here. We don't really need this chart right here anymore because we already know. We already know that information, so I'm just going to move it down a little bit. That should be good enough right there. Okay, we're going to set 30 minus 3x equal to 4x plus 9, and we're going to solve for x. So we're going to get all of our x's to one side, or all of our variables to one side of the equal sign. So I'm going to add 3x to both sides. That's going to leave me with 30 is equal to 7x plus 9. We're going to get all of our constants to the other side of the equal sign, so we can isolate our variable. And now I'm going to divide both sides by 7, so I can get a coefficient of 1 in front of my x, in front of my variable. So we'll have here x is equal to 3. So there's our answer. Now, if for some reason you're being asked to find the angle measurement, you can always take this value of 3 and substitute it back in for x right here. So 30 minus 3 times 3 is going to be 30 minus 9, which is 21. So 21 degrees would be this angle measurement. And the other angle measurement would have to be the same since they are alternate interior, but just to check it, we can always substitute right here the 3 for x. We're going to get 12 plus 9, and that's going to give me 21 degrees. So yes, this angle measurement is also 21 degrees, so it checks out. So yes, works.